welcome everybody. Looks like we might have a few stragglers coming in here, but we have a pretty full house right now. Thank you for joining us in the May Lightning Talks for Women in GIS. This month's topic is transportation, and we have 5 presentations that I'm sure will be it elicited quite a few questions and quite a few interests and quite some really great projects and so forth. My name is Jamie Dennis. I am the facilitator for today. I will be your host, but the real stars are our presenters. And I also want to introduce real quick the chair of the Women in GIS Professional Development Committee, and that is Swati Grover. She is here on with us today, so we're excited to have her here. So I'm going to quickly share my screen and just give you a little brief overview. I think I'm going to share my screen. Sure, okay. All right, so we already talked about the lightning talks. You're here for the transportation theme this month. And a quick shout out to Women in GIS sponsors. Our platinum sponsors are, I think, one of the companies, at least you guys have heard of, Esri or ESRI, as some of us old schoolers call it, and Bad Elf. Thanks to our sponsors who help keep a lot of these programs running that we can put on for you guys. We do have a long list of sponsors. These are the rest of them. If you or your organization is interested in sponsoring Women in GIS, there are a lot of different options available on our website. Okay, what you're really here for is the presentations. Today's presenters, there's actually 5 presentations. This is 2 presentations. We kind of have it lumped in here. So what we're going to do is we're going to start with Maneesh's presentation. His is actually a recorded one that we're going to share with you first, then Julia. And then these 2 presentations will be, the first one is Lucas Murray and Robert Bush on organizing customer map and data requests. And the second one will be Robert Bush with Brittanie Hambrick talking about this. But what we decided to do before you guys all joined in is we're going to have Sage Donaldson jump her up here, and she's going to be in between these 2 presentations. So just so you guys are aware of how we're going to run these things. So I think without further ado, you guys don't need to see that right now. Let me start up the presentation. Oh, I think I have to stop sharing and turn the sound back on. So hold on a minute. Forgot to check the box because it's a apologies. Zoom updated and my stuff is all changed. Okay, here we go.
Welcome everyone. I am Maneesh Prasad, founder Telematics Wire. I'm happy to share my thoughts in this lightning talk session on transportation. And I thank Ms. Swati Grover for inviting me to share my views. Today, we will see how map data is shaping the world of road transport. Maps are playing an important role in evolution of automotive. It is making our roads smarter, safer, and more efficient. Traditional paper maps have evolved into digital maps. Digital map displays in the vehicle. Modern navigation systems or infotainment panel, as we have in the vehicles, offer dynamic turn-by-turn guidance, real-time traffic updates, and more. In addition to real-time traffic information, the apps on infotainment panel allows for dynamic rerouting, suggesting alternative parking options based on availability, and even providing information on nearby points of interest, all seamlessly integrated into navigation experience. For electric vehicles, apps like Android Auto running on infotainment system can swap gas station on the route with EV charging stations. I'm sure many of you would be aware of OBD2, onboard diagnostic, OBD2 port, which is in your car. For more than a decade, vehicles have been coming with OBD2, which helps us get various data which can help us monitor vehicle health, and accordingly, we can go for their maintenance. Before we talk about connected vehicle, allow me to give a brief history of evolution of vehicles. Earlier, a century ago, transport vehicles were primarily a mechanical driven, which evolved into an electromechanical and then electronically driven vehicle, or what we call electronic control units, which are there in the vehicles. Each ECU are being run through software nowadays, and hence we also call the new tech vehicles as software defined vehicles. These STVs are now intelligent enough to communicate with the outside world, or what we call vehicle to the X communication, V2X, and also amongst themselves, vehicle to vehicle, or what we call V2V communication. Today, connected vehicles are reality, with vehicles connected with the outside world through mobile SIM. Equipped with sensors and communication technology, these vehicles can exchange real-time data with each other and roadside infrastructure. This data stream allows for better traffic management, accident prevention, and optimized fuel consumption. Imagine a future where traffic lights dynamically adjust based on real-time traffic data. Going forward, vehicle to vehicle will be connected through either DSRC, or what we call dedicated short range communication, or through 5G or 6G technology. Then vehicle will be able to warn each other of any hazard and more. GIS will continue to play a crucial role here by managing the vast amount of spatial data collected from connected vehicle and enabling insights for improved road management. An ADAS map, also known as high definition map, is a specialized type of digital map designed for use by advanced driver assistance system. ADAS features like automatic emergency braking and lane departure warning rely on a variety of sensors to perceive their surrounding. However, sensors sensor range can be limited, especially in adverse weather condition. ADAS maps provide a digital sixth sense for these systems, extending their perception beyond the range of the sensors and giving them a richer understanding of the road ahead. This allows the ADAS system to react more quickly and precisely to potential hazards. Several companies provide ADAS maps, each with their own strength and area of focus. Here Technologies offer Here HD Live Map, a cloud-based service that provides high-precision map tiles and continuously updated data layers. TomTom's ADAS map is a global solution that powers vehicles worldwide. Autonomous vehicles represent the next frontier in road transport. These self-driving cars or trucks or buses use combination of sensors, cameras, and advanced navigation system to navigate roads without human input. The potential benefit of autonomous vehicles, or AVs as they are also called, are significant. Increased safety by eliminating human error. As we know, many of the accidents are due to human error. Improved efficiency through optimized traffic flow. They will be following traffic rules to the last point, and increased accessibility for those who cannot drive themselves. However, significant challenges remain in terms of regulation, adapting infrastructure for AVs, and gaining public trust. GIS plays a crucial role here as well, providing highly accurate digital maps and location data that are critical for AV navigation. Some of the leading companies in autonomous vehicle are Waymo, which is owned by Alphabet or Google. Waymo is considered to be a pioneer in this field, having they have been in test and for over a decade. Currently, they operate robotaxi service in Phoenix, Arizona, and San Francisco. Cruise, owned by General Motors. It was earlier operating robotaxi in San Francisco till October 2023. They stopped their service after an incident. Recently, they have resumed their service in Phoenix, but it is a manned AV and they are using it for map data collection or updation. Tesla has incorporated self-driving features into its cars through autopilot and full self-driving, or FSD as they call, FSD software packages. But these are more like driver assistance system, not a fully autonomous vehicle. Several other companies are making significant strides in autonomous vehicle, including BMW, Baidu, SAIC, Geely, and Pony. Though many see future of autonomous vehicle as uncertain, but eventually we will see them in goods transport, taxi services, and more. Shared mobility is transforming how people travel. Ride-sharing services offer a convenient and often affordable alternative to traditional taxis. For planners and policymakers who are going crazy in working out parking space or additional lane in city, shared mobility may ease their challenge. Shared mobility leads to lesser number of vehicles on the road, fewer parking spaces needed, and improved accessibility. GIS it is being used to analyze demand patterns for these services, and policymakers accordingly may optimize their deployment within the cities. Finally, like maps are a key component for insurance telematics, which uses data collected from vehicle to assess driving behavior and risks. Map helps track mileage driven. For example, you have pay-as-you-go insurance program, which use this to offer discounts to low mileage drivers. Map offers like map visualization helps analyze the location data collected by telematics devices, showing where a vehicle has been driven. This can reveal patterns like frequent trips to high-risk areas or late-night driving. Map can show areas with high risk or high accident rates, traffic congestion, etc. This information can be factored into insurance premium with higher rates in riskier zones. Also, vehicle telematics data helps analyze the driving habit, based on which many of the insurance companies are offering discounts on premium, encouraging drivers to adopt good driving habits. Thank you. And if you have any question, I'll be happy to answer them over email, which is mentioned below. Thank you once again for your time and attention.
Hey, wow, that was pretty interesting. So the wave of the future is here with autonomous vehicles. And I know many of you, some of my friends here in the Phoenix area, I'm sure you have seen some of the Waymo vehicles going around town. I was on the call with someone the other day in Phoenix, and he said there was one right next to him at the stoplight. So anyway, so if you have questions, please put those in the chat. I see Lucas has one. The impact of individual privacy has had or will have on the development and use of ADAS. Very good question. So, really interesting. Okay, so we're going to go on. If you guys do have questions for Maneesh, please feel free to put those in the chat, and we'll be sure those get to him. Or if you got his email address, we'll see if we can get that on in the chat. You can always email him directly. So next up, we have Julia Brodsky. And Julia is a senior GIS analyst at MotiveCare. Is that how you pronounce it, Julia?
That's right.
Okay, great. I did it right. Okay, at MotiveCare, and it's a non-emergency medical transportation broker. And Julia comes to us with over 20 years of professional GIS experience in a variety of industries, and she's going to be discussing today a project that Motive Care has been working on in the transportation sector. So Julia, if you want to go ahead and share your screen and start your presentation, I will turn it over to you.
Okay, just to confirm, everyone can just see one slide saying using GTFS and Esri. You cannot see anything else, correct?
That is correct.
Okay, perfect. Just making sure. So yes, a lot of you probably work in transportation to some degree on this call, or maybe just are interested in learning more. So today I am going to talk about how we are using GTFS data and Esri technology to educate our members about public transit. And my next slide will go into who we are, what we do, kind of give you an overview. So as Jamie mentioned, I work for a company called Motive Care. We are based in Denver, Colorado. And what we do is we provide supportive care that enable our customers to stay in their homes longer, avoid unnecessary hospitalization, and improve health outcomes while we reduce healthcare expenditures. And we work with health insurance companies and states to provide non-emergency medical transportation, in-home personal care, and remote patient monitoring. So all three of those segments. And these services are designed to reduce healthcare costs, but while allowing our members to feel a sense of independence as well. And so I work in the mobility division, and so we manage over $40 million. Excuse me for just a second here. Okay, we manage over 40 million, sorry, not $40 million, 40 million rides a year across a wide range of transportation options, and this includes public transportation. So right now we use a combination of a few different modes of transportation for our members. We use our traditional non-emergency medical transportation vehicles. So we broker with those typical medical transportation companies. We also work with rideshare providers. So kind of tying into the previous presentation, we partner with our rideshare partners where it makes sense in markets where we have rideshare. We also provide mileage reimbursement for those who would rather have a family member or a friend drive them. And then we also provide public transportation bus passes as an option for those that are willing and able to use public transportation. And the great benefit of that also is that once the member has a bus pass, they can use the bus pass to travel to the grocery store, use it for other purposes, in addition to just going to and from their medical appointments. So right now we have about nearly $10 million in bus passes per year, and we support about 3 million rides per year. And during the pandemic, many of our passengers understandably stopped riding public transportation. So that resulted in higher transportation costs for us. But at the end of the public health emergency, we used GIS to identify passengers with bus routes to develop an individualized approach to promoting our public transit capabilities. So now that the pandemic's winded down, we're trying to again advocate members to use public transportation, talk about the health benefits of it, and again, ultimately it's cost savings for us as well. So in order to look at public transportation data as it relates to our rides, so you can imagine we have record of our rides in terms of the latitude and longitude of a pickup and a drop-off point, but we need to overlay that with public transit data to kind of understand where public transit might make sense for someone to take the bus. Obviously, if they live in a rural area, that might not be an option for them. So just a slide here just discussing what is GTFS data. So it is an open standard used to distribute relevant information about transit systems to riders. So what this is it allows each public transit agency to publish their data in a format that can be consumed by a variety of software applications. So you may have some familiarity if you go into Google Maps, for instance, you can select a route or select a to and from route and have it search for public transportation as an option. And so in order to do that, it's reading GTFS data behind the scenes to get an understanding of the relevant routes and stop times that would work for your route. And this is just a little snapshot I took from an ArcGIS Pro session of what the GTFS data looks like raw. You can see the lines representing the lines. These are not snapped to streets currently, it appears in this image. And then we have the stops as well. This is a whole network for this example of this town. And then one other thing I want to mention in terms of this particular project is we are working with a third-party vendor called Interline. And the slide just discusses who is Interline and what they do. They manage a few different areas of public transit data. They host a website, which is called Transitland. And so Transitland is an open data platform, and it's built on thousands of public transit data feeds from around the world. So they essentially partner with these agencies and aggregate all of their GTFS feeds in one central place. And also with that, they offer bulk routing analysis as well. So if you have a very complex situation, maybe you don't have the GIS tools to do it yourself, you can send routes to them and they will propose routes that make sense that are public transit accessible. And they also have APIs. So for those who are a little more technical savvy, these are application programming interfaces that if basically you upload data to their service, you can then download, return whatever the suitable routes are, again, based on this GTFS data. Now, in terms of our transit targeting campaign, one example of what we are working on right now is a campaign for South Carolina. So we believe that South Carolina is a very strong market to use public transportation, just from some of the internal ride data we have. And so for this project, we are using 3 data sources for our input. So we are using our database of existing paid ride data for year-to-date 2024. And then in order to do this, we have to kind of pre-filter the data because we need to make sure that a person is medically able to take a bus, that they don't require a stretcher or wheelchair. To some degree, a wheelchair can take public transit, but they're not totally immobile that they cannot take transit. So we have to filter that and make sure their health plan approves them to take transit, because some health plans allow it, some do not. And then we looked at the Interline transit stop data. We subscribed to their API to ping it to see what suitable routes would work. And then just one thing, if anyone on this call is interested in learning more about Interline, they do have a very robust database of GTFS data. But depending on the market, there may be an agency here or there where they do not have the coverage. So there is another resource we can look at is the National Transit Map. And so that's from the Bureau of Transportation Statistics. I provided the link here if anyone is interested. But they also are an aggregator of this GTFS data. So we contacted Interline and expressed our interest in South Carolina, and they mentioned, well, we have most of the GTFS feeds, but this particular agency we don't have. So please refer to the National Transit Map. So we were able to look up, so each agency has its own unique ID. So we were able to look up that ID and pull the relevant stop data for just that agency from the National Transit Map. And then in addition, for this project, we wanted to identify a ride that's happening today that is not being done on transit, that's within a half a mile of a transit stop. So both the pickup and the drop off would be within a half mile, because we felt that would be the reasonable maximum distance that one of our members may want to walk to get to a transit stop. And then these are some maps I just created just to give you an idea spatially of where we have our rides in South Carolina. So this represents the origins of all of our riders in the state. This represents the various destinations. So these could be medical facilities, grocery stores, really anywhere that our members would like to go. And this represents the stops that were extracted from Interline as well as the National Transit Map. This is more of a zoomed in view. So this is an area of Charleston. And again, being healthcare, we have to be sensitive with our patient data. So this data has been graphically modified a bit to put it in a general place, but just to give you an idea, this would be an example of a ride that we would deem transitable. Here's the pickup location. Imagine this is someone's home address. They are within that half-mile distance of a transit stop, and then here's their destination, also very close to a transit stop. So we would like to identify rides where we have this combination with the proximity of the transit stop. So what we did is we have our data that we send to the API. And so this is the data that is returned to us. So we basically supply them with the pickup latitude and longitude and the drop-off latitude and longitude and the date and time of day. So the system, the API understands, because obviously transit service may differ on a weekend versus on a weekday. So it gives it that sense of when a rider may realistically want to take a ride. And then the API will return to us for each ride we supply it. It will repeat again the coordinates we're looking for, pick up and drop off, and then it will supply by leg the mode the person will need to do. So imagine the first leg, the person may need to walk to the bus stop. The second leg, they are taking the bus. The third leg, maybe they need to transfer and go to another bus. So that type of information, as well as the agency route, stop information, as well as distance, duration, walk time and distance, and transit time and distance. So we have all that information that will help us really target who would be appropriate to take public transit. So then we check the results to see if these itineraries are suitable for the rider and meet our threshold criteria. So, in addition to the person being within that half-mile walk distance, we want to make sure that the number of transfers is minimal. We would want to look at maybe a maximum of 2 transfers. And the walking distance, again, we might want to further refine that because certain clients, insurance plans we work with, they may have a rule that they do not want their members walking more than a quarter mile or things like that, other things we need to consider. So once we've applied those filters, then we can have our contact list for the campaigns where we can reach out to see if our members would like to take transit. So that pretty much sums it up as what we're doing in terms of GTFS. And then there was one other additional piece we found interesting. So the Centers for Medicare and Medicaid Services also have a guideline they published at the end of last year where they're saying that someone who subscribes to their services, they would really like the person to go to their nearest medical provider. So, maybe they would prefer to see a doctor 30 miles away, but the guidelines state that they really should go to their nearest qualified medical provider. So, I was curious to know spatially, is that really happening? So we started working on another exercise to kind of look at that. So I pulled this data from Business Analyst. These are all the pharmacies in this part of town in Charleston. And again, here's a pickup and a drop-off location. You can see in this case, we're just using the sample of pharmacies in this case. The person is being picked up at home and wanted to be dropped off at the Walmart pharmacy on this side of town, but you could see there's a number of pharmacies that are closer. So just something else to consider, as a healthcare organization, that, are we really abiding by the CMS guidelines? Can we encourage our members to travel to a pharmacy that's closer to them? Can we save money by doing so? So there's a lot of different specialties and things we can look at. We're just kind of scratching the surface with this, but I found this interesting as well. So that is everything I had.
Okay, that was awesome. Thank you, Julia. That was there are a few questions. We're gonna hold off. We still have 3 more presentations to get through, so we'll hold off for Q&A at the end. But there are some in the chat. If you want to respond directly in the chat, feel free to do that as well during the next presentation. So thank you to Julia for that presentation. Very interesting stuff going on. All right, so next up we have Robert Bush and Lucas Murray, right? You guys are doing the next one? Okay, and they're going to be talking about organizing customer map and data requests. And Robert Bush he's been with the Arizona Department of Transportation for over 25 years now. Fun fact is I used to work with Robert. in my stint at the Arizona DOT. Anyway, and he is now a program manager overseeing the statewide pavement and photo log data collection. And with him on this presentation is Lucas Murray, who is also with the Arizona DOT, and he is a senior GIS analyst there and the HPMS analyst, which is the Highway Performance Monitoring System there. So I'm going to turn it over to Robert and Lucas. Go ahead.
Well, thanks, Jamie. Want to appreciate you, first of all, for inviting us to today's topic. Saw your post on LinkedIn and said, hey, let's get some people out there from ADOT, so we appreciate it. Today's topic, although we're transportation related, I hope can go to any of you, regardless of what industry you're in or what you're doing, that deals with multiple map and data requests throughout the calendar year. In ADOT, we get requests from the director, the state engineer's office, a lot of key management personnel, a lot from the public, and anywhere else that you can imagine. So we do a lot of different requests in analytical work with GIS data or cartographic work also with GIS data. So there's a lot of stuff to go on. When we first started about 15 years ago, saving these map and data requests so they could be reused, because we'll have people come to us, send us an email of a photo of a map that was created 10 years ago and say, hey, can we get an update to this? And it started to become a problem because we didn't know who did it, when it was done, or anything like that, although we kept it. Go ahead to the next slide, if you would, Lucas. So we had a repository over 15 years of map and data requests. The problem was there was no consistent organization to it. We had organization based, and when I say organization, I mean in folders and things like that, subfolders in what they were named for the data or for the year. Some were by month, day, year. Some were name a requester. Some they put the type of map on, things like that. But there was no continuity to it, nor any way to really find what was going on. Next. We also found that some of the data was stored offline. Through the years, different people and personnel and management would do different things and, come in, new manager, new way of doing everything. And that was very difficult over the years, because unless, like myself, that had been with the agency for so long, the new people, or as people change and new analysts come and go, they couldn't find anything. They weren't able to find previous maps or the data associated with the maps. Plus, when you went back and found them, you found that the MXDs were broken, usually not working. The data wasn't there. And even if you knew what the purpose of the map was, a lot of it was still very opaque to what was done years ago. Go ahead, Lucas.
All right, so I'll take on this slide. So, as Bob was saying, I mean, we just had all these different systems of organizing the request, and it was difficult to use. So we needed to come up with some method that would help us to put these requests in some sort of standardized, organized fashion. We needed a method that was going to be consistent. We would be able to apply it across all map and data request projects. We needed it to be intuitive, where transferring the knowledge would be seamless. We could teach it very easily to new employees. It wouldn't be hard to educate somebody on how to use it. And we needed it to be sustainable. We're in a period now where we have a mix of some data requests that they still want paper maps, they still want PDF maps, that kind of stuff. All of that can be worked on the desktop like we've been doing for decades. But now we're seeing more and more data requests or map requests for things that are going into ArcGIS Online or into Portal for ArcGIS, story maps, dashboards, all that. So whatever method we came up with, we needed it to be applicable across all these different platforms. So we decided to apply the KISS method. And if you've never heard of this, it's keep it simple, stupid. We needed something that was going to be easy to apply, and it wasn't going to make things any worse than what they already were. So we started out by organizing our projects by decade. As Bob said, we have projects going back over 15 years. So we wanted to be able to quickly and easily be able to find projects that were made, 10 plus years ago or 5 years ago or whatnot. If I click on an individual folder, it'll open up and sort the projects by year. So at least if somebody said, oh, I think the project was done a couple of years ago, I'll know, okay, 2022, I can look in that folder and it greatly narrows down where I need to search for projects. We then needed to apply a new way of sorting these projects, and we came up with a new project ID. Since we're sorting everything by year, we decided that the project ID should include the year. So we have the 4-digit year in it, for example, 2024. And in this case, we applied whenever the project started. So if the project started in 2023, then it gets a 2023 project ID number, even if that project is continuing today, which you'll see an example of a little later. We then applied just an easy unique ID number, a 3-digit number. So you can see on the right here, we have 2024-001 is the first project in 2024, and all the rest of the projects go in sequential order. It's simple, it's easy to teach, it's easy to understand, and it makes it a lot easier to find projects. In addition to the project ID, we also need to employ some way of tracking these projects so it's easy to find them. So we have a separate spreadsheet with metadata about each project. So here you can see the project ID in this spreadsheet is on the leftmost column. If I'm starting a new project, I just simply scroll to the bottom of this list, look for whatever the next available project ID is, and that becomes my new project ID. So that way we don't have any projects overlapping with each other. And then we have just basic information about the project, the name, the description, when it was started, when it was due. In other fields, we have who was the requester and that kind of stuff. So now if I know who's requested it, I can search by that. If I know that it has to do with traffic, I can search by that keyword. So it makes it a lot easier to narrow down to the specific project that I need to look for. And with that, I'll turn it back to you, Bob.
Thanks, Lucas. So now what you're seeing here is a screenshot of the implementation for 2024 of just a sample of what we got here. We created a subfolder based on that unique ID, and that's the key here, is the unique ID. Go ahead, Lucas, to the next one. You can see here, the first picture you see in the upper left is inside one of those folders that we just showed you, the same with below it. And you'll see that that unique ID is used in the MXD, it's used in the PDF, and other things. It's used in the geodatabase. Next. Here we have a map that Brittanie put together, who you'll meet in a little bit. And we have a disclaimer up in the upper right corner there. When we zoom in, you'll see that the project ID is there on the map. So if we get a copy of it or a screenshot or a PDF, whatever it is, we have something to work with. Those of you that are analytical and very particular to the data might notice that the date on the map is April 2024, but the project ID is 2023-015. The reason for that is that this particular map is the second generation of new data added to old data and stuff like that. So the project actually started last year and has a 2023 date on it, or a project number on it, but it represents now a map that was done this year. So you can go back to the original data set and get all the information. Next. Here's online, the same thing working here. You can see the unique ID, both in the tag, so if we need to search for it, and up on the title of the AGOL app there. Go ahead, Lucas, with the next one. That should do it. Please go ahead and send us emails or reach out to us if you have any questions. As I said, we kind of took a lighthearted approach to this and came up with, if you're having problems organizing your data or anything of that nature, that Lucas came up with this idea. It was very simplistic, and although it was really a heavy lift getting all the old data organized, the end result is paid for itself tenfold now in finding and locating data. Thank you.
Thanks, Robert and Lucas. That was awesome. So very, I think we all struggle with organizing stuff. And I see Jesse has a great comment there in the chat before we zip over to Sage's presentation here about Love the cohesiveness across environments. Consistent metadata is the key. So that's a great comment there. So we're going to save the questions. There are a few questions in the chat if you guys want to respond directly to them there, or if we have time after the final presentation, we'll go to them then. So next up, follow on to that, is Sage Donaldson. And Sage is going to be talking to us about resilience and security in transportation. Sage is she is also with the Arizona DOT with over 5 years of professional experience in GIS and transportation. And she is currently the Data Analytics and Federal Reporting Program Manager at the Arizona DOT. So I'm going to turn it over to you, Sage.
Thank you. Thanks everybody for hanging out. Yeah, so I'm going to do a presentation on resilience and security in transportation. This came out of an effort from the Transportation Research Board. Each year they pick several critical issues to focus on and kind of steer the agency's congressional leadership towards. And one of the proposed topics last year was resilience and security. And I head up that focus area. So this is sort of going through that. It's really going to focus in on the data sets required to establish good resilience and security in your transportation network. So just quickly going to walk through what we'll talk through today. It's going to be defining resilience as whole, talking through some examples of good ways that states have implemented transportation resiliency, the data necessary, so the specific data sets that we found were most important, and then some applications of GIS in transportation resiliency. So transportation resiliency involves a number of different types of hazardous events, but overall, over the past several years, we've seen a lot of hazardous events stemming from changing environments, climate change, or otherwise hazardous climate and weather events. Extreme weather events have increased in frequency and intensity, flooding, wildfires, hurricanes, and tornadoes in the past 5 years. We've also seen sea level rising and also insects, rodents, and other human-caused events that are leading to hazardous materials or hazardous weather events taking place, causing disruptions to transportation networks. So that can stem from anything from things like oil breaks that we've seen in Minnesota and Wisconsin, as well as our increasing weather in Arizona and the western states. So in order to really develop a mitigation strategy, you have to start with defining resilience. And there's a lot of different ways people define resilience. And so we've just kind of got a few different examples here. The first one is from the US DOT. It's the ability to prepare, absorb, respond, and adapt to adverse events. Colorado DOT has done some really awesome work with transportation resiliency. And so their definition is the ability for communities to rebound, positively adapt, or thrive amidst changing conditions and challenges, whether that's human or natural caused. And it's to maintain the quality of life, health growth, and durability of systems and economic vitality during an event of some kind. After doing a bunch of research and looking through things, we ended up on the definition, the topic focusing on how GIS can enhance the ability for an area to recover or mitigate effects of a major disruptions. So our goal was to really focus in on the GIS part of transportation resiliency and try to really show how GIS can really positively affect your disruption or your mitigation strategies. So just some general concepts associated with transportation resiliency. Roads and transportation infrastructure that were built many years ago were not built with the set of conditions that we're currently in mind. So they really weren't built to withstand so much degradation throughout the nation and even throughout the world. They were designed 40, 50 years ago and weren't up to standards that they are today. One of the interesting things that I found is a lot of the asphalt that was put out in a lot of the East Coast was really not built to withstand the higher temperatures and are having times of like random combustion in the asphalt and things falling apart. So they really weren't designed with the standards of today in mind. Another kind of important thing is that a lot of investment in inequalities were not justified when a lot of these transportation systems were put in. So a lot of the vulnerable communities are not seeing the same level of economic vitality as well as just attention in their transportation systems. And, looking at equitability in resilience, it's important to strive to make resilient communities regardless of the income bracket or regardless of the jurisdiction. So those are just some other concepts to keep in mind about transportation resiliency, and more so just to show how holistic this topic is. So we developed a story map, and I'm not going to pull it up now because story maps can be finicky, but I just more so wanted to throw out there that it's here. It basically walks through different types of events that can happen and also the different infrastructure that happens. So here, this map on the side here is the ports of entries and port of supply chains overlaid with fire instances. This second one right here with the yellow lines are our electrical grids. And this one on the right with the green and purple and yellow are roadways and trails, train tracks and railways associated. So you can kind of see the breadth of how a weather event or some other kind of event can really take hold of all of your transportation systems. So the first thing that we kind of talked about when looking at GIS transportation resiliency was identifying some good data sources. So one of the things that is really awesome is that as part of the Highway Performance Monitoring System, which is a report that all states have to give the federal government each year on the condition, durability, capacity, volume of each of their roads that are going on. This data is all publicly available and really, really useful for planning a transportation resiliency program. So to start, a very important thing that we've seen now is bridge infrastructure is really, really important in understanding the condition, quality, and time since you've surveyed a bridge. So the first thing that we've said is always look at your bridge infrastructure. What is it and how long has it been there? What's the quality? Another really important one is the National Road Network. This is a big network that combines all of our roadways that go cross states into one spatial database. So that way you can start aligning with what other states' roadways look like and where you connect, so you would know where you need to communicate. The other really important one is the National Freight System. Supply chain during COVID we saw was a huge fall that we didn't expect. So understanding your freight routes and understanding where your freight routes could fall apart is really important to your supply chain. But essentially putting together all of these different types of data sets to start looking at what your capacity for resiliency is. So Arizona DOT did their own resiliency plan. I'm not going to go through this too heavily, but essentially they focused on these 5 action strategies: prevention, response, recovery, investigating what it was, and learning from those actions. So they focused in on projects to do with drainage. Flooding was a really bad thing in Arizona. Our roads really weren't built for flooding, especially in the southern part of Arizona. So they focused in on what the life cycle of a specific road or a specific drainage area would be. And so these are just some images of those. And here's just a before. This was a drainage in Chinle, Arizona, which is in more northern part of Arizona. You can see how degraded it is. You can see that there's rockfall happening and just some general roadway elements that aren't stable. And this is it after. So they put in this specific type of rockfall mitigation and also built up a concrete structure for when you have to drive over it. Vermont is another really good example. They had several 100-year storms and flooding events happening between 2011 and 2023. The EPA found that it increased 70% rainfall in the Northeast overall. By putting a bunch of different mitigation strategies together, including ducting tunnels and a few other drainage type things, they had 200 versus 4 bridges affected by their 100-year rainfall, and 500 miles versus only 282 miles affected. And so when Hurricane Irene hit, a lot of places that were really poorly affected before had much better mitigation, and the roads didn't go out quite as drastically. So I kind of want to quickly talk through our really important one that's just happened recently, the Francis Scott Key Bridge that went down in Maryland. I wanted to show this graphic as just to look through at the disruption, how you're impacted in the recovery. The biggest thing here is that your resilience happens all in the impact stage. So firstly, it's looking at where this happened, what was the route that it took, and what roads were specifically affected. So this is just an aerial image of that. Next, you have to look at who all you need to communicate with. So this is the overlining counties and cities in Maryland. So Baltimore City, Baltimore County, and these Anne Arundel. So you need to be looking at who you should be communicating with. You need to look at how many people could have been on this bridge and what the capacity of it is. So here's this one. It was built in 1958 and has over 100,000 crossings each day. And then here's the amount of money that's been put into it. So you can track how much rehab's been done to it. We can look at how many miles have been affected by it. So it's generally an interstate road, which is around 2,000 miles. And then also look at the volume. There's around 14,000 cars that average cross this each day. And then again, looking at the specific lane miles of what cities are affected. So there's 735 miles affected in Baltimore City in general. So you can see how widespread this will be. And then lastly, you can just kind of put all the pieces together to see all the different places that are going to be affected by this in the shipping prospect of this. So taking it even outside of road transportation and looking at how many different ports will be affected. So nothing can go into the Chesapeake and Baltimore harbor for the foreseeable future. And so accumulating that into the different ways that you can apply this with GIS, doing network analysis on freight, blending different data to look at underserved populations, 501 communication, and looking at other transportation networks that could be affected. And that's all I got. Thank you, everyone.
Whew, 10 minutes in. Okay, so that was awesome.
Right.
The great thing about these lightning talks is there's so many great presentations and such a variety on one theme. I love it. Thanks, Sage. So next up, I know hopefully you guys can stick around if we go a little bit past the hour. That would be great. I also put a link to Sage's story map in the chat there. Okay, so next up, we're going to have Robert Bush and Brittanie Hambrick, who are going to be talking about creating a centralized GIS data repository at ADOT. You've already met Robert, but Brittanie is a GIS analyst with Works Consulting out of Phoenix, Arizona area. So hope you guys take it away.
Thanks, Jamie. We'll try to keep this reasonably short and sweet. You'll see a lot of common tendencies with our first presentation. Believe it or not, the reason for the first presentation was leading to this second, and that's base data. What we call base data is data that's used on a regular time by a lot of people, but it's shared data, such as traffic information or where light posts are, or the state highway system, or SHS, as we call it. This is data that's used on a regular basis, whether it's for analytical or cartographic reasons, but it's shared. And over time, go ahead to the next slide, Brittanie. Over time, you'll see that we had lots of problems with our data. Geodatabases all over the place that had the same data, annotations galore all over the place. We didn't know what was authoritative, what was original, who the owner was. There was no plans on how to keep this stuff current. It was a massive mess, to say the least. So what was the solution? Go ahead to the next slide. Well, the solution seemed to be pretty simple. Let's consolidate everything into a single location within ADOT, and that's where Brittanie came into play. We started getting the most current and authoritative data sets for all of our base data. And similar to the map and data request, we created a spreadsheet that tracks all the data, the metadata associated with it, who has it, where did we get it from, and what's the last time we updated it. And I'm going to hand it over to Brittanie now.
Thanks, Bob. So the fun part begins, implementing the solution. We did find it easier to keep the data stored in file geodatabases because ADOT is still using ArcMap for the time being. So with the geodatabase pared down, as Bob said, we started updating those data sets with the most current data from trusted sources. And this was to just undo any inadvertent edits that had been done to our past base data. And we also decided to further organize our data by breaking it down into 3 GDBs. So instead of just having one giant GDB with everything, we now had 3. So you could go and look for ADOT specific layers or external layers or HPMS data in those different GDBs. We knew that we wanted this base data to be beginner user friendly, so we created some custom data sets. This just made it easier for people who aren't used to querying or filtering data to get exactly what they need. And it also speeds up the process for those of us who use these same data sets a lot. And then the last thing is we added metadata to the feature classes. This is just to easily make sure that you're using the right data, because it gives you this description here in the bottom. And you can also check when the last time it was updated right here in the metadata. So another thing that we did, as Bob mentioned a minute ago, is that we used this spreadsheet to kind of track our data. So this was actually created by my predecessor, and we kind of tore it apart and repurposed it to track a whole bunch of things. So we have in here the last updated date, and we also have when it should be updated next. And we also have the data owner information in here with their contact info. So if you need an update, you know who to contact. And we also have the location of the data listed. So if you can't find what you're looking for, you should be able to find it in this list and then look under the internal location so that you can find where it's at. So this is an example of one of those custom data sets that we created. So again, this is all meant to be very user-friendly, as well as for everybody who does this kind of more frequently. So it was created with that in mind. This is the state highway system layer. So this is normally a giant feature class with all of the Arizona Department of Transportation owned roads. But for cartographic purposes, you just really don't need everything most of the time. So we created this simplified layer that removes all the ramps and the overpasses and the frontage roads. So you kind of are left with this just nice, clean data set for cartographic purposes. And then another thing we did was we created some example template MXDs. So this one specifically is for the shields layer. And shields are generally pretty time consuming to symbolize every single time you go to create a map. So each of these little shields for the highway system and the interstates, they're made up at minimum of 2 layers, but the interstate ones, I think, are either 4 or 5 layers. And we counted down through the windows you have to click through to get to the page to edit these. And I think it's like 7 clicks in. And you have to do it for each of them individually. So it's so time consuming. So we created these MXD templates. And the idea is you can just open this MXD, copy this layer and paste it into your own map, and the symbology from this will come straight over for you. So you don't have to spend time doing this every single time. And then we did do this for the statewide layout, so that if you're working on like a whole statewide map, you have an easy access to the symbology. And the same thing for the metro areas, so like Phoenix, Yuma, Flagstaff, Tucson, and Arizona. And with that, it's back to you, Bob.
Thanks, Brittany. So now that we have all that put together and everything like that, we decided to create a shareable folder inside the ADOT network that would have all that. You saw a picture of it earlier with the 3 GDBs. We have all that information in one location. The nice thing about it is it's a read-only location for nearly all of ADOT. Just within the GIS team can we edit it and stuff like that. So you're not going to have a lot of the problems that we had previously of a GDB being shared with multiple users that might edit one of the feature classes on the GDB, not realizing they're altering other people's map and data. So this way, if people want to use it, they can take a copy of it onto their local drive, on their computer, make a copy of it on their network, whatever they want to do. The screenshot you see here is just a part of the email that was sent out to all ADOT identified Esri users, whether that's ArcMap, ArcPro, AGOL, whoever in ADOT has access or uses Esri software. They got an entire email describing what was there, how to use it, and to reach out to us if they had any questions. Next. I know we're over on a couple minutes. We'll wrap it up here real quick. Kudos to Brittanie for finding a picture to represent me with the crew cut and the flat top and the glasses. So hopefully you get a laugh out of that graphic. But looking ahead, our plan is to convert everything over to ArcGIS Online once the agency as a whole moves over to ArcPro. Since we use roads and highways and everything like that, ArcPro has been a little bit slow to be implemented within ADOT, but we're hoping to come along and be up to speed, hopefully before the end of the year. But the advantages of ArcGIS Online are obviously, for those of you that know it, is easier for ADOT people to get to it, especially the metadata, and what Brittanie was talking about, by having that second GDB that was non-ADOT data, people could start getting that independently on their own, and it's one less thing we have to worry about. So let us know if you have any questions. Next, Brittanie. And I just want to follow up with this. Although I did the presentation earlier with Lucas and this one with Brittanie, all three of us were very cohesive and put together both presentations, not just for Women in GIS, but the work behind the scenes to make both of these projects happen at reality at ADOT. So thanks for their help.
Excellent. Great job. Such great presentations. Thanks for those of you that's sticking around here for a little bit after the hour. Super thanks to all of our presenters, from Maneesh Prasad, who's shared a video with us, who's not here today. Julia Brodsky, thank you so much. Robert Bush, Lucas Murray, Sage Donaldson, and Brittanie Hambrick. Thank you guys so much for sharing your work and insights with us today. If people want to still stick around, if you have questions, if somebody wants to raise their hand and you want to have a question, or if you want to unmute and ask, that's fine too. If there's anything that anybody wants to share here, I know some people may need to get off. There's been a lot of great questions in the chat, and I see our presenters. Thank you for responding to them in there. I really appreciate that. So thank you so much for everyone for joining us here on a Friday afternoon. With that, I don't see any questions. I think that you guys handled them all well in the chat. Thank you again, everyone. I'm going to put, for those of you still here, Women in GIS, our next, speaking of organizing, our next workshop is on visualizing your workflow and organizing your to-do list with Tim Nolan, who's a great instructor. I put a link to the information for that next workshop in the chat there, so if you want to join us. All right. Well, thank you, everyone. Have a super wonderful weekend. And again, thank you to our presenters. Really great information. Thank you so much for sharing all your work with us. So, great weekend.
Yeah, thank you. Thank you, everyone.